We're going to do a startup on this Lauson RSM. I believe it to be 1939 because of the carburetor number. It's a 74D Tillerson. Anyway, according to McDonald's carburetor site, they went to a different number in 1940. This engine has been put together with several different parts from different engines. I found the marine engine, the original marine engine, was in real bad shape, wasn't usable. But what it did have was the marine oil pan, the marine intake manifold, 3/8 pipe intake manifold, and the 74D Tillerson carburetor. It also has the extended pickup on the oil pump. And it came with this half of the coupling. Everything else is from different RSC engines. It's got an audio tuned straight pipe, and it runs good. I fix it up and put some vinyl graphics on it, bling it up for show. Try to attract attention. That's using Greg's philosophy. Anyway, we'll try to fire it up. Carburetor was in bad shape on this. Got a lot of JB Weld repairs and basically runs on the high-speed circuit. Got machine nuts JB'd onto the bottom of the bowl. Keep the thread. Little throttle lever I made up. This 1 horsepower at 2,300 RPM, and this is not the smallest engine they made for a boat inboard application. They made one smaller. This is a 2-inch bore. They made an 1 3/4 bore. Carburetor is leaking. Anyway, it'll be a good holding cable engine for my shows this summer. Okay, this is a Lauson RSC crankshaft. Actually, it's the same crankshaft that's in this engine here. This is the front end. This is the back end. Has the coupler fastened onto it. I'm showing you this because all Lauson air-cooled engines have ball bearing main bearings, front and back. They're one of two that I know of, Wisconsin and Lauson, and I believe the other air-cooled engines have may have a ball bearing in the back, but a bushing in the front. And this here is for the governor. The governor would have been hooked to this thing, but on an inboard boat engine, the propeller, the size of the propeller is the governor, limits the RPM. This is the cam here, and it drives the oil pump. So anyway, in a boat engine, you have to have a thrust bearing or some kind of thrust set up so the propeller, the action of the propeller, the thrust of the propeller, isn't trying to push the crankshaft through the block of the engine. And in this case, this front bearing acts as the thrust bearing, and it takes the thrust load to the magneto plate. And the magneto plate, of course, is bolted to the front of the block. This bearing here isn't really set up to take the thrust, because it is connected to the crankshaft. There's nothing stopping this part of the bearing, whereas this bearing is bottoming out the magneto plate right here. So this is one of the reasons you have to have a thrust bearing set up in an inboard engine, so you don't eventually push the crankshaft through the engine. Okay, thanks for looking at my video.